So here we have n data points which are assumed to have been generated from a Gaussian distribution, normal mu sigma square, and we are asked for the expression of the log likelihood after removing the constant terms, right? So the log likelihood for a continuous distribution is nothing but the joint PDF, right? And since we assume that all of them are IID, since it's a random sample, the joint PDF is nothing but the product of the individual PDFs, right? So I can say this is nothing but the product I running from 1 to n f of xi mu comma sigma square, right? Now that is nothing but product I running from 1 to n. The distribution of normal mu sigma square is given by 1 by sigma under root 2 pi times e to the power minus of 1 by 2 times xi minus mu upon sigma whole square, right? Now this can be written as 1 by sigma into, so 1 by sigma to the power n, and then 2 pi to the power n by 2. Then we have an e to the power of minus half of, and then since it's a product, on top of it will go as a summation. So summation I running from 1 to n, we have xi minus mu upon sigma whole square, right? Now if I take log of this, so the log of L would be minus n of log of sigma minus n by 2 log of 2 pi, and then we have minus of half of summation I running from 1 to n xi minus mu upon sigma whole square, right? And this term is a constant term because it doesn't have mu or sigma. So uh, the expression that they're asking for is nothing but this term and the last term, which is this one. So here the next question is, we have a GMM and then we have plotted the frequency uh, of the data, and from the frequency plot we can observe that there are essentially three mixtures, right? One being centered at somewhere around -6, and the other one being centered at 0, and the other one being centered at 6, right? And it's already given that all the mixtures have unit variance, right? Which means sigma 1 square the same as sigma 2 square, sigma 3 square, and all of them are 1, right? So first question is, what is the mean of mixture 3, right? So it can be easily observed from the diagram that the mean of mixture 3 mu 3 is nothing but 6. The next question is, if the point -3 is observed, what is the probability that it has come from mixture 2, right? So this is nothing but probability that this particular uh, data point -3 belongs to the second mixture, given that it is observed, right? Given that x is equal to 3, or sorry, x is equal to -3, right? This can be written as probability of uh, observing -3, given we are drawing from the second mixture, multiplied by the probability of drawing from the second mixture, and then divided by the probability x equal to -3, right? So now we can write this way. There's a probability of z equals to 2 times probability of observing -3, given that we are drawing from the second mixture, and divided by, we'll take the sum of all j running from 1 to 3, right? Probability z equals to j, and again drawing -3 given z is equal to j. So since we have a continuous distribution, right, these probabilities, this one and this one, will be replaced by the PDF of the normal, right? So this will be replaced by normal PDF -3 with mu and sigma square as required. Similarly, this will be also be replaced with the PDF of normal, right? So let's do that. At the same time, one more thing to be noticed is that we are already given that pi1 is 0.7, pi2 is 0.2, and pi3 is 0.1. This is already given to us. So what is pi1? So, or what is pi2? Pi2 is nothing but probability z equals to. So we can write pi2 times normal minus 3 given mu2 and sigma 2 square divided by pi j times the normal PDF minus 3 when mu j and sigma j square are given, and then sum them from j equal to 1 to 3, right? So this would be pi2 is 0.2, so we write 0.2 times the normal is given by, so since all of them are unit variance, we can write this as 1 by under root 2 pi e to the power minus half of x minus mu2 whole square, right? But what is mu2? Mu2 is 0. So this would be minus 3 whole square, which is 9, divided by, first of all, we'll have this term itself, and then we will have the term corresponding to pi1 or the mixture 1. That would be 0.7 multiplied by 1 by under root 2 pi, and then e to the power minus of. Now, for the first uh, mixture, the mean mu1 is equal to minus 6, right? So we can write this as minus 3 minus negative 6, which is 6 minus 3 whole square, which is again 9. So this is e to the power minus 9 by 2. Now if we look at the third mixture, we have 0.1 into 1 by under root 2 pi e to the power minus, again we have, since mu3 is equal to 6, right? What we can say is that minus 3 minus 6 is minus 9, and then square of that is 45, so that is minus of 45 by 2, right? Now it's easy to observe that the 1 by under root 2 pi will get cancelled, right? And then we will be left with 0.2 times e to the power minus 4.5 divided by 0.2 plus 0.7 times e to the power minus 4.5 plus 0.1 times e to the power minus uh, 45 by 2. So now when we compute it, this term, which is e to the power minus 45 by 2, is a very small number. So it's in the range of uh, 1 into 10 to the power minus 11, right? So we can ignore the term, and this would be somewhere equal to 0.2222, right? And this is our answer, right? And this indicates that given we have a point minus 3, right, the probability of it coming from the second mixture is 0.22, right? Because minus 3 is somewhere here, right? And it has a higher chance of being drawn from mixture 1 instead of mixture